Hey, good morning, guys. Travis Ross here with Pacific Safety Solutions. Today I'm going to attempt to walk you through a rigging process. If you're watching this video on your phone, you might need to watch it on a laptop so you can use your phone as a calculator if you want to follow along. Enjoy.
We have here a basic tower configuration. From right to left, the tower is rigged at 160 feet. At 90 feet, there is an obstruction that sticks off of the tower 7 feet. We have the tagger out 75 feet and the capstan hoist out 110 feet. The antenna weighs 325 pounds. The question is, what is the tower going to feel in the process of this pick? Before we get started, let's do a little example on how to find an angle in a right triangle. In order to find this angle, you will need a calculator with a scientific function. If you have an iPhone, go to the calculator app, tilt the phone long ways, and the scientific function will appear. If you have an Android phone, download a calculator. I recommend an app called RealCalc. Once you have the calculator needed, identify the angle in the triangle you are looking for. Draw an imaginary line out of the triangle. In this example, the number we get out of the angle is 10. Put 10 in the calculator first, then divide by the other number, 18. The number you get should be 0.55555. For an iPhone, with that number 0.55555 on the calculator, press second function, then press the tangent key. The number you get should be 29. That means you have a 29-degree angle. If you have an Android phone, keep the 0.555 in the calculator, then press shift, then press the tangent key. You should come up with the 29 degrees. Let's try this one. Same triangle, we're just looking for a different angle. Draw the imaginary line out of the angle, and the first number you get to is 18. So put 18 in the calculator first, then divide it by the other number, 10. You should come up with 1.8. Keep that number 1.8 in your calculator, press the second function, and then hit tangent. You should come up with 61 degrees. If you're able to successfully complete these angles, the rest of these exercises should be fairly easy for you. In this example, first we want to find the load line angle, which is that angle right here. 7 is the distance the obstruction protrudes off of the tower. 70 is the distance from the obstruction to the crown block. So there's your triangle. We need to find that angle. Or 7 divided by 70 equals 0.1. Keep the 0.1 in your calculator, hit the second function tangent, and you should come up with 5.7 degrees. On this tagline angle factor chart, we have to the left the load line angle, and we have at the top the tagline angle. What we just found was the load line. Our angle we came up with was 5.7, so we need to round it. In this case, we always want to try to round toward the worst. So between 5 and 7, 7 is going to be the worst. So that's the number we're going to keep, 7 degrees. The next we want to find is the tagline angle, which is this angle right here. The tagline angle is the height of the obstruction, 90, divided by the distance the tagger is away from the tower, 75. We do that, 90 divided by 75, we get 1.2. 1.2, second function tangent, you should come up with 50 degrees. In our tagline angle factor chart, we have 7 degrees load line angle, and we have a 50-degree tagline angle. We put those together, and we come up with a 1.18. That number, 1.18, is the tagline angle factor. So what we do with that is we multiply that times our load. In this case, we have 325-pound antenna times 1.18, and we should come up with 383.5. What that did is we're basically adding weight to the antenna because the tagger is tagging it and pulling it down. So we come up with 383.5 pounds. The next triangle, or the next angle we would need to find, is the block angle factor. All right, the block angle is the distance the capstan hoist is away from the tower, 110, divided by the height of the crown block, 160. And we should come up with a 34.5 degree angle up there at the top. We have to remember that the load line angle was 5.7 degrees. So we need to subtract that from our 34.5 to get the correct block angle. In this case, we get a 28.8 degree. This is a block angle factor chart. We are at 28.8 degrees. When we're putting it into a chart, we always want to round it to the worst. In this case, between 20 and 30, 20 would be the worst, so we would round it to 20. In that case, we get a 1.97 angle factor. What we do then is we take the 1.97, we multiply it by the load. In this case, it's 383.5 pounds, and we get 755 pounds. We've just calculated the approximate rigging forces onto the tower, 755 pounds. So let's go ahead and recap what we just did. The first angle we found was the load line angle. The top triangle, we found it to be a 5.7 degrees. The next angle we found was the tag line angle, and we found that angle to be a 50 degree. The next angle we found was the block angle, and the triangle up at the top angle, we found it to be a 34.5 degree angle. So with those three angles combined together, we have solved the equation. Here's a little exercise example for you to practice on your own. If you get this correct, you will find this to be a very interesting pick.
Pretty interesting stuff. If you have attempted to calculate that last example, leave your answer in the comments and let me know what you find. I'm sure you'll find it to be a pretty interesting pick. All right, guys, take care. Have a good day.